Welcome back, guys. On our previous video, we introduced this topic of probability, whereby we say that to calculate the probability of absolutely everything, what you have to know is that probability is equals to what you want divided what is possible. What you want is what we call the total number of favorable outcome. What is possible is the total number of sample space. And also on my previous video, we talk about why are we learning about this, what is the purpose actually of the probability. So if this is your first time watching my videos, I beg you to go and watch my previous so that you can be able to understand this kind of stuff of probabilities in more details. So something that I forget to mention in my previous video is that probability, it has a scale. It has a scale between 0 and 1. So when you calculate the probability and you get 0, it means that kind of stuff, it is impossible to happen. It's not going to happen. But once you calculate the probability and you get 1, it means that kind of stuff, it is 100% that is going to happen, But if you get something that is between 0 and 0.5, it means that kind of stuff is less likely to happen. But if you get something that is between 0.5 and 1, it means that it has some few chances that kind of stuff is going to amount, So also, I also promise you that we are going to do some everyday life examples so that you can be able to see how you can be able to use probability in your everyday life. And to do that, I prepare some few examples that we're going to do right now so that you can be able to understand probability in more details. So without wasting more of your data, let's just do some few examples. So here's the first example. The first example goes like this. It says that you've been stressing out because your crush has been ignoring your text, and you are not sure if it's worth it sending her another message or not, So out of the 10 messages that you sent to your crush, she replied only twice. Once when you say hi and she say hi back, okay. And once when you wished her birthday and she replied thank you. Oh boy. The other 8 messages were double tick with no response, So what is the probability that she will respond if you send her another message today, So this kind of stuff, of probability, guys, can be able to save you from assuming a lot of stuff. So now we want to calculate the probability. What are the chances actually that she will respond if you send her a message after sending 10 messages and then she only replied twice out of those kind of 10 messages? So we want to know the chances that once we send another message today, she will respond or not. So how are we going to do that? We know that to find the chances or to find the probability of absolutely everything, what we have to know is that probability is equal to what? Is equals to what we want. What is it that we want here? We want to know if she will respond or not. So on our previous past 10 messages that we sent, how many times did she respond to us? She only responded what? 2 times, which is twice, So the total number of favorable outcome is how many? Is 2, which we are going to write 2 here. Then divide by what? Probability is equals to what we want divided by what is possible. What is possible is whereby we're going to add the possibility of not going to respond and also the possibility whereby she respond. So we add it to find the total number of sample space, which here when we add this 8 and 2, we are getting 10 messages in total. So which means we're going to divide by 10. So this 10, if this one, when we put in a calculator, we're going to get 0.2, and 0.2 in percentage form, we're going to get 20%. So we have 20% chance that she will respond when we send her a message. So is this kind of probability more likely to happen or less likely to happen? To find that, we just have to bring our scale here to see if this kind of stuff is less likely to happen or more likely to happen. So here's our scale. So 20%, since between 0 and 1, 20% is going to be somewhere here, which is 20%. So is it less likely to happen or more likely to happen? Between 0 and 0.5, it means that this kind of chances is less likely to happen. So the importance of probability is just that it helps us to avoid the false hope, Isn't about like giving up for texting here. It's about thinking clearly and protecting your energy. Not every risk is worth repeating. So we cannot like risk again and send her another text, man. You can see that she's not responding, dog. So yeah, let's just do another example so that you can be able to understand this in more details. So here's another example. This example, it says that you want to go out with your friends during the upcoming holiday, but there is one big problem. You have to ask the permission from your mother, from your mom actually, and you are not sure if she will agree this time or not. The last 5 times you asked her to go out, she said yes 3 times and no 2 times, So what is the probability that she will say yes this time? So this kind of sort of probabilities can be able to also help you to know the chances that you have to get something that you want. So now we want to calculate the probability or the chances that when you go and ask your mother again to go out, she will agree or not. Instead of us assuming, we want to calculate that kind of stuff, that how many chances do we have for each and everything. So to calculate the probability, we know that probability is equals to what? It's equals to what we want divided by what is possible. What we want is the total number of favorable outcome. The favorable outcome is what we want actually. What do we want? We want the probability that she will say yes, So how many times did she say yes to us? She said yes 3 times. We're going to write 3 divide by what? By what is possible. What is possible is the total number of sample space. It's all the possibilities that are there, whereby we're going to add this 3 times and 2 times, which is 5, So we're going to get what? 5, So what is the chances that she's going to respond to this? So this, if we round it off, we're going to get 0.6, which is approximately 60% chance that she will agree when we go and ask the permission to go out, And so is this 60% more likely or less likely to happen? So that's where we are going to put it in our scale. So 60% is somewhere here. And from 0.5 to 1 is what? It's more likely to happen. So now you are going to go to your mother or to your mom with certainties. You are going to know, like, I have 60% chance that my mother will agree this time. You have calculated this kind of stuff. You are not just assuming. So that's the main aim of probabilities, to provide you with sure calculation that you will agree or disagree. So let's just do one more example. So here's another example. So this example says that a grade 10 learner has completed 3 school terms. This is a school name. Has completed 3 school terms so far. So out of those 3, she passed 2 terms and failed 1 term. As you know that at school there is 4 terms. There is term 1, term 2, term 3, and term 4. So this learner has passed term 1, and let's say she failed term 2 and passed term 3. So now she wants to know if she will pass the 4th term or not. What is the probability that she will pass the 4th term? So now you can be able to calculate the chances that you have to pass the 4th term using the calculation, without you assuming or without you saying that I'm not going to pass or I will pass, So there is a way to calculate the chances that you have to pass or not passing, So how are we going to find that kind of probability? We know that probability is equal to what? Probability is equal to what we want divided by what is possible. What do we want? We want to know if she will pass or not, So how many times did she pass for the last 3 times? She passed how many times? She passed 2 times, So which means in total, the total number of favorable outcomes is going to be what? Is going to be 2 divided by what? Divided by all the terms that she has completed, which is 3 times. So if you round this one off, you're going to get 0.666, something like that. And if you round this one to the percentage form, you're going to get 66.7% if you round into 1 decimal places. So this learner, he has 66% chance to pass. So is this kind of 66% chance more likely to happen or less likely to happen? That's where we bring our scale here, So 66% is going to be somewhere, which is 66.7%, So this is more likely to happen. So she has more chances that she will pass the 4th term. You can also do yours to check if you will pass the last term or not using the probability. That's the main aim of probability, is to help you make smarter decision and also make you stop you from assuming some certain information. So here's the last example. So they say in your class of 25 students, your teacher every day randomly checks the homework of 5 students and do the corrections. So each and every day your teacher just give you a homework, and when you come, you just check only random 5 students there. So but today you forget to write your homework, so you are panicking. You're not sure if you will check, if you will randomly check yours or not. So what is the probability that you will check yours today? So now probability, you can also be able to use it to understand the chance that you have if you don't do certain thing. Right now you didn't write your homework, and I hope by now when you are watching this video, did you write your homework or not? You didn't write your homework. So what are the chances that your teacher is going to check your homework tomorrow or not? So for that kind of stuff, you have to calculate. You don't have to assume. You just have to calculate it. So based on this data, we can be able to calculate the chance that you have for your teacher to check your homework. So to find that kind of probability or the chances, what you have to ask yourself, that probability is equals to what we want. What do we want? We want to know if you will check or not. You will check yours or not, or what are the chances that you will check yours. So we have to ask ourselves, how many times did he check the homework? Actually, he checked 5 times. He checked for 5 students out of this kind of 25, which means we're going to write 5. Out of how many students? Out of 25 of them. If you round this one to the decimal places, you're going to get 0.2. 0.2, which 0.2 is the same as 20% chance. So there is 20% chance that today, if you don't write your homework, your teacher is definitely going to check your homework. So if you have not done your homework and you're still watching this video, go and write your homework, because your teacher will definitely check the homework.